Fabulous. I'm as well doing fabulously. So in this particular session, we're going to talk about transportation. We're going to talk about transformation in transportation. And the range of topics is quite wide. If you have read through the contest winners who are present, it's going to be, we're going to cover a lot of territory. So, so everybody who is here representing one of the winning teams. So there's 4 teams and one is calling in from somewhere, yeah?
Yep.
Looks at Lara and Lara is busy. Good. Somebody's calling in, right?
Yeah. Yes.
Okay, great. So everybody who's on a team here, why don't you stand up? And I'll get you guys to just quickly introduce yourselves and your team. Oh yeah, sorry, you got to use the microphone. Let me hand you a microphone. All right, so you come up. Everybody has to redesign the process. Come on up, introduce yourself. We'll start with you guys, and we'll go to you. Hold on for a sec. We'll let these guys do theirs. So go ahead. And you can pick it up and grab it, yeah.
I'm Emil Jacob, and this is the...
No, it's on, it's just not up.
Hello?
Yep.
And we're gonna present a concept for mini elevated trains. And our goal is to see what has been so far the barrier to why elevated trains never made it as a mass transit solution. And we're proposing a solution.
Awesome. So we'll hear lots more about that. Why don't you guys come on up? Just introduce yourselves. No big.
Okay. Hi, my name is Jeff Olinger, and this is Julia Hansen. We are the founders of the Flycycle high-density bike parking solution. And our approach is an incremental type of environmental urbanism that seeks to improve the experience that people have when they're parking their bikes, but then also creates a space savings and more efficient way in which bike storage can be incorporated into the urban environment.
Awesome.
Hi, my name is Omkar Kulkarni. Our team name is Airmac Innovations, and we are from India. We are just graduated aeronautical engineers. He's my friend.
My name is Saurabh Deshmukh.
And our project name is a cross-flow air turbine auxiliary power unit. It's basically a zero fuel, zero emission replacement technology for the conventional auxiliary power units used in aircrafts. So we'll explain it later if you have some questions. That's it.
Awesome. So you can see that our range is quite wide. So do we have the folks? Hey.
Hi. This is great. I can see myself on TV there. I'm Valerie Thomas from
us too. Yeah.
From Georgia Tech, and with my collaborator Surya Arul Silvan. Our proposal is addressing the challenge of scaling up the production of biofuel for aviation.
Thank you. That's perfect. As I was saying, the range of things that we are dealing with in thinking about transportation and transformation in transportation is quite wide. And it'll be quite interesting to see where the intersections are and how they come about. So we do have look, there's me. A set of videos. Yeah, we ready to go with that? You guys are awesome. Okay, we'll let that roll.
We are Surya Arul Silvan and Valerie Thomas from Georgia Tech. To reduce greenhouse gas emissions from aviation, we propose strategic investment to scale up aviation biofuel. Aviation has recognized the need to reduce greenhouse gas emissions, and they have proposed to reduce emissions by 50% by 2050. The options that are available For cars, such as electric vehicles or hydrogen fuels, are decades away for aviation. But biofuels are ready now, and they can have substantial immediate impact. Aviation can meet the greenhouse gas requirements of renewable biofuel and can reduce emissions by 50% compared to petroleum. There are already 3 biofuels approved for commercial flight, and there are already airlines that are using these fuels regularly. Those include Cathay Pacific, United, and KLM. To bring down the costs of biofuel from the demonstration stage where we are now to a real commercial viability, there needs to be investment to bring those costs down.
China is a country with strategic investment in biofuels could work because of its dependence on imported petroleum and its track record of work in new energy technology. China has successfully channeled investment in solar photovoltaic technology and has brought the cost way down. A similar approach can be taken to bring down the cost of aviation biofuels. Various feedstocks should be considered to develop a holistic supply chain network. Increased production can be achieved by investment from the government. Offtake agreements and international partnerships can propel a continuous market for biofuels.
Our next step is a workshop in China, bringing together leaders of the biofuel industry, of aviation, and policymakers in China. We welcome your ideas, participation, and contributions. Thank you.
Auxiliary power units on airplane are used for various purposes, such as to start the main engines, as well as to produce electricity and provide feed air for the air conditioning unit. In this process, they consume a lot of fossil fuel, nearly about 70 pounds per hour. That's lot. Greenhouse gas emissions of these fuels is significant, and airplanes also has to carry extra fuel to operate them. Conventional fuels produce a lot of noise. Although their greenhouse gas emissions are not in large quantity, but the contribution to global climate change is significant.
Cross-flow air turbine is a green technology in auxiliary power unit. We wanted to bring a revolutionary idea to challenge the conventional auxiliary power unit. Trying to do this, we came with simple yet feasible idea which can completely replace the conventional APU if developed in proper direction. So, how it will replace? Well, CFAT is capable of all the work which normal APU does, and that too with no fuel and low noise. CFAT is lightweight, hence batteries can be used to store excess electricity.
CFAT uses no fossil fuel. It works on simple air turbine principle. It extracts energy from high velocity air when airplane is flying at optimum altitude. When air passes over the blade, fan rotates with high RPM, which in turn rotates the generator shaft. This simple motion produces enough amount of electric power which can be stored and used for onboard electric requirements. A generator is placed inside the cross-flow fan. A duct is also provided to transfer the large volume of air into the air conditioning system. Airflow can be controlled using the intake and exit door. When airplane is stationary on the ground, it can use stored battery power to run and provide air for air conditioning unit. We are also working on to develop CFAT in such a way that the incoming air can be compressed and used to start the main engine.
We are constantly working on its design to reduce drag penalties by making it more safe and aerodynamic. With proper guidance and expert help, CFAT can be a reality. CFAT can be implemented at various stages. Aircraft manufacturing companies and government policies can come forward and take benefit from it.
In all, CFAT technology is future of APUs, and we see it as a potential solution to reduce the impact on climate. We have not witnessed it. Do you?
since the early days when the first streetcars, buses, and subways came into service. And the thoughtful solution is to look for elevated mass transit, but there are issues with space, such as monorails that are limited to wide spaces. And private transit presents issues of visual light because of multiple responses that are needed. The whole solution for this train is for a small size train that can run on thin tracks that are easily assembled, and has a list of the solutions to how the tracks intersect with smooth crossing. Here we see that the wheels at the crossing that normally travel on the concave part of the wheel on the oval tracks. At the crossing, we use the outer part, and the crossing for the lower train on the lower track uses the auxiliary track to be lowered, so that at the crossing where the tracks are opening, the train is supported by the bottom track that we see here until it crosses and then it continues right into the lower track. The C train fits effectively in any dense urban landscape as long as there are at least two lanes of traffic on sidewalks or concrete poles. The tracks are intended to be as thin as possible.
Many cities recognize that biking is an helpful, energy-efficient alternative to smooth motorized transportation and are experimenting with bike lane infrastructure and public bike services. But well-designed bike parking has been neglected, although it's an essential component of the area's bike community. Bike racks are frequently unavailable, uncomfortably used, difficult to access, or unsafe for bikes. The demand often far exceeds the supply. The Flexible presents a new way of thinking about bike parking, in which elegant designs and functional form come together to expand the public's access to user-friendly bike parking. Flexible raises the front wheel of the bike, and the front handle frequently frustrates cyclists and makes bikes prone to tip over. This added stability reduces the amount of space needed with bikes, allowing in the space of 5 20 and posting capacity for space saving. Office buildings, schools, commercial and transportation centers frequently install dozens of bike racks in a single location. Space savings of this magnitude open up new possibilities for design and help to add additional capacity in locations that are already space constrained. Flexible makes bike parking accessible and easy to use for more people and is a beautiful, space-efficient solution for the owners. gaining popularity as a viable transportation alternative, and the infrastructure supporting this movement must keep up. We are proud that the bicycle was founded in the heart of Campus Square. We've developed multiple prototypes using the skill of local artisans and listening feedback from the community of cyclists and property managers. Our next step is to manufacture and sell municipalities and we'll also present our concept of the UN Type 3 Commons and effort as part of an exhibition on universally accessible design underpinning sustainable urbanization. We've been helped along the way by extraordinary members of the academic, commercial real estate, manufacturing, and service sectors. The story is truly one of Yankee innovation and partnership.
As you can see, I'm probably going to get her back, right? As you can see, our range of topics is pretty wide, all aimed in many ways at transforming the particular pieces of the transportation world that they are focused on. I'm going to ask for a representative from each of the teams to come up, join me here, and we'll have an opportunity. Go ahead. We'll have an opportunity to move a little out of the way. I'm going to ask a few questions. I think most of you have probably been through this now. So I'm going to ask a few questions, bring up some topics, and then we'll have a chance for you, and these guys will potentially ask questions of each other. And then we'll have you will have a chance to ask some questions. We'll use this microphone. We'll park it over here so that we get it all on file. And our buddy from Georgia Tech will be back in a few minutes. She's watching me, right? Hi. Wait. Hi. So my first question is it's probably the hardest one. Although many of you probably have already thought this through pretty carefully. And that question is, obviously the big reason we care about all these issues is the sort of urgent need to reduce carbon emissions. So for each of you, if you were to think about sort of cost compared to tons of carbon avoided, I'm not going to ask for an answer. I'm going to ask for how would you think about it? How would that calculation look? What are you looking at when you think about that calculation? So, start with you.
Yeah. Obviously, initially the cost of the CFAT, that like we call it the cross flow air turbine, short for a CFAT, and we call it. The cost for the initial cost will be the higher to implement it, no doubt, because the advanced material will be used to make the system lighter, and to make perfect, because we are in the initial ideation stage. So yeah, obviously the initial cost will be the higher. But if we implement it in the larger portion in many countries through the various stages, like just told that through government policies, through manufacturing companies coming forward, implementing such systems, so the cost can be reduced if it produces in massly. So yeah, we see it as a CFAT can be coming to reality.
So if you were to, so in this case, there's the technology you're developing is a pretty straight substitute for an existing technology.
Yes.
And so, which is, as you well know, there's multiple ways to innovate in a field, and a substitution of technology for one which has qualities that we're looking for. In this case, not using fossil fuels to power. although there's probably some fossil fuel use as incremental use that happens there. So if you were to imagine that substitution, then what does that substitution potentially get you from a carbon perspective?
Actually, conventional auxiliary power units in airplane, they use a lot of fossil fuel, as I said. And our system, it does not use a single drop of fossil fuel. It does not require any kind of fossil fuel, and it works on a simple air turbine principle. It extracts energy from the wind passing over the fuselage in the high speed at the cruise altitudes. So basically, on that part, the carbon is, and the system is comparatively lighter than the conventional auxiliary power units, and that's why we can use the extra weight for the storage, more storage power for the batteries, and to produce more power and store more power. So on that part, we can work and develop in that way.
That's great. I'm going to ask the same question for you.
So in terms of reduction, it would depend a lot on what scale it would be adopted at. So let's say if we as a society one day wake up and say we've been sitting in these 2-ton piles of metals to move around and burn the earth pretty much to get them moving, and we say we can get something elevated moving around on the power of the sun and the wind because it wouldn't take that much energy, the cost and versus the reduction would be I don't want to use the word huge from Donald Trump, but it would be huge. You can imagine the scale. If 90% or 95% of the time when you travel, you have something that you hop on and it takes you where you want to go versus having to drive and versus having the experience you had today getting here, which my guess is 95% of us had some degree of frustration to getting here. So it would depend on the scale. So that's the best of the best scenarios. On the smaller scale, if we just manage to put this model on some bus lanes that currently say on Broadway here, where buses go and in different places, we could reduce emissions enormously just by getting people to have partially access to the city versus having to go to the red line or driving and so on. So it would depend very much on what scales it is adopted at.
It seems in many ways like this is a great technology for rather than the straight substitution, like say with a bus line, that for transportation lines where right now it's not super feasible, there's other things that get in the way. How would you think about it? Like say the whatchamacallit trail, help me out here. What's the railroad line? The Grand Junction, thank you, sorry. Like the Grand Junction line, perhaps.
Yeah, so the easiest to implement is, of course, where there is no opposition from the public, but the focus of our design is...
That won't happen, let me just say.
That's why we're here today. And the way we thought of the design is to look at everything that's been done in the subject in the past and why hasn't it made it up there, since it could be, the way we see it almost like the internet of mass transit, like we solve moving information around, it's a solved problem today. Moving people around, it's as primitive as 100 years ago, really. So how can we solve this problem and to make it in a way that's actually at least not have opposition, but maybe even attractive in a lot of ways to have this model in place?
Mm-hmm. So I think that's a great lead in to thinking about FlyCycle and sort of how do you think about what the effect of FlyCycle, which is, you know, in the scale of these innovations, is tiny. You can carry it, but tiny yet has big reach.
Yeah, and that's exactly sort of how we're imagining our impact is through a sort of incremental strategic implementation of our technology into an already existing demand, which is bike parking. Every building, every institution, and every municipality in some way or another is looking at connecting transportation at multiple scales as a centerpiece for transportation and climate reduction and carbon reduction plans. So for us, addressing the the activity of bike parking and improving the activity of bike parking itself, as well as looking for a way to create a more spatially efficient way to park bikes, is our way of contributing to what we hope to be a much more integrated and larger transportation approach to reducing carbon. And as Jim mentioned, our project does have the ability to be broadly implemented at a very small scale. It's very economic. And in that way, we hope to rapidly change the way in which people are connecting bike parking and bike transportation in general to a larger consideration of urban mobility.
So let's shift scales. Hey. Hi. So I'm going to ask you the same question, which is, how would you think about the sort of cost relationship carbon reduction? Not necessarily what's your answer, although if you have one, that'd be awesome. But also, what are you considering?
Yeah. So there, if we want to replace all of aviation fuel with biofuel, get rid of petroleum entirely, that's a pretty big a transition. So one way to think about it is, first, there's one issue of thinking about it. How much money do you need to drive down the cost of biofuel and really establish a totally new global industry? But I think your question is really getting at, okay, let's say there were the potential to replace all of petroleum used in aviation. How much might that cost in terms of a carbon solution? So you gave me a few minutes to do this this calculation. So there are a couple of ways of thinking about it. One way would be, all right, so let's say the eventual biofuel 20, 30 years from now is going to cost some more than the current petroleum. Petroleum is really cheap. It's really hard to beat that at large scale. So just playing around with some numbers, if you had a biofuel that cost $1 more per liter than petroleum, you could imagine that you could easily get there. But if you go and just crank out, well, how much extra money is that per ton of carbon? It's, around $2,000 per ton of carbon. That's a lot. That's really, if you're looking at good ways to reduce carbon, is too high. But another way to think about it is, let's say the carbon reduction that you're willing to pay. People throw on numbers like $100 a ton or something like that. $100 a ton for carbon would add a relatively small amount to a gallon of biofuel. So what we're looking for here is, can we get the cost of biofuel low enough at large scale that the additional cost is acceptable to the airlines and to the military, other users of biofuel? And then also, can we find other benefits to biofuel that can help buy down some of that extra cost? I would, if we can afford to pay, in the $100 per ton carbon, that can give you just a few cents. So you need to be having your biofuel cost low, and you need to have some additional reason for wanting the biofuel, and that was one of our ideas of looking to China.
That's a great question. So this is the first, thank you, it was lovely. First time we've really looked at one of these technologies relative to the sort of international pricing of carbon. So obviously a hot issue, bad words. It's a big issue, something we're all thinking about, especially in Massachusetts right now, where there are potentially carbon pricing statutes that are coming up before the legislature, among other areas where this is the case, and internationally it's beginning to happen. You mentioned the price of $100 a ton for carbon, which is a sort of a logical price, but we all know low, that we well could end up with a higher price for carbon, but it's not going to be an order of magnitude more.
Yeah.
So that brings up, that sort of sets up a very good question of like, well, if that's the case, and this is a substitution technology, what are the other benefits? Are there other benefits, other costs associated with this process that really get us there? How are we doing for time? We're probably up with our 10 minutes, right? Okay, so I'll keep everybody here. We'll keep that thought and see if there are folks in the audience have questions that you would like to ask of these folks. Yeah. So I'm going to ask you to go ahead and speak into the mic so that everybody can hear, because otherwise our guest from Georgia Tech will not hear us.
So we've got a biofuel. It's called ethanol. And my understanding of ethanol is that it's not very successful. Actually, it costs more in carbon emissions to grow the corn than you get from. Love to hear your opinion wherever you are on that camera.
Sure. So a couple of answers. There have been there's a recent paper I've seen on corn ethanol arguing that it uses more carbon than it saves. I don't think that calculation is correct. And it's true, if you make ethanol from corn and you power your ethanol production, I don't know, with a coal-fired power plant, yeah, it's going to have high emissions. But recently, as there's been actually some effort in figuring out that you want to do this process in an energy efficient way, the use of energy in making corn ethanol has fallen. Another piece of the answer here is that aviation biofuel is a different thing. It's not ethanol. It's there are different mixes of molecules that are largely drop in, at least to a 50% level. And so you are looking at a different type of molecule that you're producing. And also, this wouldn't be something that would be made, say, from corn. There are some proposals to make aviation biofuel from seeds that can be grown as cover crops. There's a lot of potential in waste materials. And actually, for our idea, for anybody's idea, it's very important to have a very low cost feedstock. So in the US, aviation biofuel is being made from beef tallow now. They're actually flying out of LAX, Los Angeles Airport, using beef tallow. So looking for those low-cost biofuels, there have been some Chinese researchers that have looked at waste fats from the restaurant business. So there are low-cost sources that you can get, and developing ways to have very low carbon production of these is essential.
Great answer. Thanks. One of the things that I realized once we started talking here is that we are looking at this interesting chain of transportation innovation that runs from international travel to essentially the intersection of international travel and airports to public transportation that potentially would take you from an airport to what might be called that last mile or last quarter mile of bicycle transportation on the streets. And that there's this nice chain of connection through these technologies. Other questions? I'm going to switch it up a little on sides.
So my question is for the C-Train team. So I took the T this morning, and there was hardly room to stand on that green line at a rush hour traffic time of day. And there's still a massive amount of people in Boston who are driving everywhere. So that's not even really taking cars off the road. That's just people using public transportation already. And just from the design on your video, the train looked small so that it could have the small lines that didn't have to be large, but have you thought about the capacity of people that you can really transport with a train that's so small, and how frequently you'd have to have those trains run to really have sort of a replacement for heavy car traffic?
Fortunately, Dr. Ashwani Kumar, who has a PhD in transportation and has been crunching numbers like this for a long time, could answer this better than I would.
You have a ringer.
Yes.
Yeah, that's the first question we answered while designing the system. And actually, capacity of the system is around 6,000 pph/pd. Let me explain how exactly that happens. One train can carry 20 passengers, all seated. But since entry and egress is so fast in this case, that we can run these trains every 12 seconds. Like theoretically, we can run it every 12 seconds. And even if taking the realistic scenario where we can run 4 trains every minute. So it's about, we have sort of taken away some of the key learnings from the existing metro system. What the existing metro system does, it has 7 or 8 cars. Each car can have just 10 passengers, or it can even have up to 250, 300 passengers. In our system, load is predictable. We know there can't be more than 20 passengers. So the whole structure becomes light. We are not designing it for 250 passengers. We are designing it only for 20 passengers. So the structure, the vehicle becomes light. All the structures that it is supported on, those structures become light, and capacity is still very high because we run them very frequently. Typical metro trains run every 3 minutes, 2.5 minutes at the most. So we are running it, we'll be running almost 15 trains during that period in the same time interval. We'll be running 15 trains. So that's how we make up for the capacity. But still, I won't say that capacity of this is exactly the same as metro. It would be, if you consider a typical metro system, its capacity can go up to 50,000, theoretically. Though people will be highly uncomfortable if you go for those capacities. But in our case, we can install this system at various roads. Not just, we need not come up with just this system in one street, because our system will cost around 1/15 of a metro system. And that's why we are pitching it as Internet of Urban Transportation. In the sense, you put it on all possible streets, wherever people permit it. It would not even cause the so-called visual pollution, because it doesn't have, it's like trolley, you have lines of trolley buses. So it could be something bigger than that. And you have arches, you have street lighting, you have arches and things like that. We can come up with interesting materials, which could be semi-transparent, so that even the visual pollution part goes down. So that's why we say that in metro, you have to accumulate people artificially, and then you have to carry them to certain points. But in this case, you can take them from point to point. You can have frequent stations, and you can move people around much faster. So even artificial aggregation of people would not be there.
So there's a sort of model here. Go ahead, I'll let you in just a sec.
Sorry,
Go ahead.
One more really important point, and it's somewhat counterintuitive, that with the capacity question. So the train is not just like a subway. If I put the train here in Cambridge on Broadway, on Cambridge Street, on Prospect Street, and so on, when you go to Boston, you can enter Boston from 20 different streets. So the capacity is spread out. It's so the numbers that we did, we more than meet the demand. Much better actually than the current system, because it goes on every major street rather than the clustering.
So what I was going to say is that there's a sort of an additionality here, where there's a logic of, look, we've got very expensive devices that have very high capacity, that live in the ground or live on large scale things above the streets. But then there's lighter scale, lower cost, sort of more distributed capacity that happens in other settings, much like streets do. It's an interesting model. So we'll have one more question here, and then we get to break up a little.
I have a question for the people proposing the ethanol. What about using the waste to energy process, and through pyrolysis, the PET bottles, etc., also produce fuels, liquid fuels that can they be utilized for aircraft, etc.? Because that movement is moving very rapidly now, the waste to energy transformation. the burning of yeah.
Yes. There are, am I on the air? Am I on? All right, yes.
Yes.
There are, so yes, and I believe that one of the current producers of aviation biofuel is using municipal solid waste through some kind of pyrolysis or, heat and pressure Fischer-Tropsch type process. And what's kind of interesting and cool is that ASTM is now going through the process of certifying aviation biofuels, and there are about 9 of them, and 3 of them have already been certified, and then 3 more are coming, and then 3 more are coming later. And so a lot of them are there's a wide range of them, and consistent with these kinds of pyrolysis processes, and also that would produce, generally, if you're making aviation biofuel, you're also making some definitely diesel, and you can have other co-products, and that also all goes into the equation of making a viable industry. Yeah, so it wouldn't be ethanol, it would be something like jet fuel and diesel.
Right, which, so thank you, that's great. I looked to the screen, which of course is looking away from you. The interesting thing from my perspective here in thinking about something like the scale and action associated with biofuels for aviation is the scale of industry that is required and all that comes with that, like certification of fuels. And there's, the issues around aviation fuel are very heavy, quite a bit heavier than the issues around bicycle parking, though you'd be surprised at the issues around bicycle parking. So we have a couple of minutes for more questions. If other folks have questions about things within this structure, before we break up and have an opportunity to talk individually with each team in the breakup sessions.
Thank you very much. Dave Doucette. Actually, I have a question about the power generation that goes to the aircraft. Obviously, there's some loss in the air flight based upon this generator basically changing the aerodynamics of the plane. Drag. Thank you very much. I was looking for the word. But how do you see that? Because therefore there is some loss of fuel use in that. And if you've done some analysis to show how that compares to effectively what the gains would be by the less weight and all the other aerodynamics.
Yeah. So basically, we are just said that this is an ideation stage. This system. So what we look in this system, it cannot be like if we developed it in like in product end product. The design can change. So as we see in this system, the air intake and outlets are at the same point. So if we develop in another direction, the intake of the air can be taken from the one side and the outlet can be other side. So the aerodynamics can be maintained. Okay, yes, sir. And so yeah, and so yeah, for that we can compensate that loss with the weight that the drag losing drag created by the system. We can compensate with the weight reduced by the replacing auxiliary power units, which are the conventional auxiliary power units. So we are reducing the weight. So the same we can if we cannot reduce the drag causing emissions, so we can equalize it with the compensate with the reducing weight using the same system. Yeah.
So essentially what you're saying is there's an opportunity to reduce weight within the system, which potentially will reduce fuel use, but there's probably an increase in drag, which potentially increases fuel use. And there's a question about, okay, how comparable is that? Which is a good question. Certainly in many transportation systems, the power relationship between the power available and the power needed is somewhat overweighted to the power available, which means that there's some room to play there, but I don't know about aviation
I
at
just
all.
want to add one thing. Then this whole system can work and can give work like the same as in conventional APUs. It has various purposes, same like the conventional APUs. It can also take the whole volume of air directly from the atmosphere and use for the air conditioning. So we don't have to depend on the engine compressor to take the bleed air and to transfer them into the air conditioning manifold to distribute into the whole aircraft. So the CFAT, the whole system can serve 3 to 4 purposes, like power generation, giving bleed air for the engine startup and for the air conditioning. So it can, and that are all cost of and zero fuel. So that's what we're basically working on. So then, as I told, this is it's in very ideation stage. It can be developed in other direction also. We can replace the position of the CFAT. Yeah, that's
So
it.
we'll have one more question. Nope, you don't want it. Okay, we're not gonna have one more question. Heck with you. And now we have an opportunity to break up into groups with the 4 teams. So we'll have one, see how do we wanna do the one? We'll do it right over here. Okay, right. So for Georgia Tech team, you can you can gather right at the back here. Otherwise, okay, fly cycle. Is back there, right? And the last one over in the far corner. Okay. All right, got that. Here's your chance. So wait, this is an opportunity to ask more questions and to bring your expertise and offer solutions and solution generation. This is an opportunity to take some of these ideas and bring what you know to that process. So rather than necessarily ripping them up, it is, although feel free, it is an opportunity to bring your own expertise into the process. So let's go ahead. We'll break up into the groups. And we'll probably try and gather together right at about 12:25 to just wrap it up. Okay?
So, yeah.
Go ahead, you should do it.
No, they can hear it here.
So you don't need this anymore.
If you'd like to be with aviation biofuels, we'll be right around here. Can you sit with it here?
I need to manage it from here.
Oh, okay. Hi, it's Laura. I'm the project manager with Climate Collab.
Thank you very much. This is such a great process, and thank you for providing a virtual opportunity. I think it's right in the spirit of reducing the impacts of aviation.
Well, we think it's really important. And it's also a good way to reduce carbon emissions.
Exactly.
So, all right, so people are just kind of mingling right now. They're not really moving to any circles just yet. Oh, there I am on the big screen. So, yeah, great. So we're still getting things together. I'm going to turn you around so other people can see that you're here. Yes, thank you. So hopefully it's not too loud. Valerie, can you just say something?
Sure. This is Valerie Thomas coming to you live from sunny Atlanta, Georgia.
Yeah. Okay, so we're just going to go out to the hallway. It's just a little bit too loud inside the room.
Okay.
So we're going to go into the hallway. It's too loud. We can't hear them. All right. So just
Oh, great. No, it's okay. It's all right. Wait, we're just gonna go into the hallway. All right.
I'm not a speaker, so it's...
All right. We'll have to grab chairs though. So we can just camp out here. Hi. Hi.
How are you doing?
I'm good. I'm.
Are you busy?
I am busy.
Okay.
Yes, but thank you. Let's talk later. Okay.
Somehow this feels like being on a hospital gurney.
This is like one of those things that people talk
Taken
about
down
today,
to the
like
operating
building
room.
robots so that you can have a telepresence system and you can drive yourself around and interact
Yeah.
with people.
Yeah, that would be great.
We actually do have robots, but we didn't have enough for one for each room.
Uh-huh.
We didn't have 3. We only have 1. So we didn't employ them this time around. Okay, we can hear you a lot better now, Valerie.
Yeah.
Great. Thank you very much for doing this. I really appreciate it.
Yeah.
Great.
Hi.
Hi.
One question.
Do you want to introduce yourself?
Oh, I'm Eduardo Fracassi. I come from Argentina.
Ah, great. My mother's from Argentina.
Your mother?
Yeah.
Oh, great. Well, my question is, why is it so difficult to calculate the cost of fuel, the fuel cost? Why?
For biofuel?
Yes.
So it's going to be different companies making this biofuel using different feedstocks and with different capabilities. And so it's like projecting the cost of a meal at a restaurant. They're going to be a little bit different. And we're still at the point of bringing down the cost. Now, there's some kind of data in that there are airlines and the U.S. military is buying aviation biofuel. There are 3 companies producing in the U.S. and several that are producing other places in the world. And they're not releasing their data on the actual contract price. So that's why we don't really know. And they all say it's cost competitive. But what that means, we don't exactly know. But you do, and I do them techno-economic analyses where you calculate out what the price should be.
Why cannot the price be included in the price of the tickets?
It could be.
The question is whether some airline companies would then have more expensive ticket prices and whether they'd be able to incur that higher cost. That would be one of the questions that I'd raise, right? Because there's a few companies that are using Altair and whoever else right now, and whether their ticket prices have to go up to absorb that extra cost. And they may see value in that, but whether their customers will see enough value in that is, I think, still remains to be seen. Sorry, my name is Alexander Dale. I'm a AAAS fellow at the EPA. I'm in the Transportation and Climate Division, so we work on the renewable fuel standard that handles a lot of biofuels and aviation fuel.
Well, that's really great. So you're based in Washington?
I am based in DC, yeah.
Yes. So I was the APS Congressional Fellow for 1 year, so I know your program. So that's so right now you have the airlines that are kind of experimenting with using biofuel. So the idea is to scale up production so it could be a larger fraction of their flights. Right. One question is that it's easier. So if you're going to be scaling up biofuel production, you would be producing at a location and then it would go probably to an airport or a small number of airports. That's what we see now. And so there's some flights like Cathay Pacific is flying its flights from Toulouse, France to Hong Kong are biofuel. And so then so they have to be they must be doing this calculation internally of how do we price this, how do we absorb the prices as we scale it up if we're going to be focusing our initial biofuel entry into the fuel system at a limited number of airports.
Are they able to include a carbon price from the EU on aviation or a cap as part of their financial accounting?
Could you just say your question again, please? I got that last half.
The EU has some amount of carbon awareness on aviation, so are they able to include that in terms of the financial incentives?
I don't know. However, the International Aviation ICAO has committed to reducing its greenhouse gas emissions somewhat substantially. And so there is, unlike in the land transportation, in aviation, there's actually market pull to get biofuels. And so it's not only in the European Union that there's a drive to start using biofuels, but also by American US flag carriers, knowing that there's pressure on doing something about the greenhouse gas emissions of aviation. And aviation as a whole seems to be growing. More and more flights are occurring, more and more fuel is being used. So for aviation, the challenge has been, because there are now producers coming online that are producing at viable costs, whatever that means, there's almost more of a kind of logistics and scaling challenge than price per se. Although price is a huge challenge, and you gotta, you're constantly working against the price challenge. You gotta have really low cost fuels. You gotta be scaling up. Aviation is attractive because the scale is smaller than for all of ground transportation, and also from the perspective of working out the logistics of making this work through the supply chain. The natural first stops are moderate-sized airports, not necessarily the largest ones, although we're seeing that at a large airport in LAX, we're seeing it at Hong Kong. In Georgia, however, we're doing biofuel at the Savannah airport. It's an airline that's interested, and it's just easier to mix in some biofuel there than it is, say, at Hartsfield-Jackson Airport, which is one of the world's largest airports. So the relatively small scale of aviation compared to ground transportation, and then the ease of having a much tighter fuel distribution system possibly makes aviation biofuel a way to build a much larger biofuel system as well for other kinds of applications.
Can you introduce yourself first?
Oh, sorry, Kelly McGill. I'm with Linnea Solutions, a sustainability and resilience consulting firm. Can you speak briefly about whether, from your perspective, the biggest barrier to widespread adoption of aviation biofuels is technological, financial, infrastructure, or developing a sustainable enough sourcing stream for raw input materials?
Okay. The challenge it's getting these facilities at a kind of modest scale up and running and integrated into the supply chain. The cost has been brought down on a lot of them. And that's one reason we thought about China as being, the US is doing a good job. And I think we're going to see a lot more in the US, but in China, they've shown through their other activities on, say, photovoltaics, of being able to kind of stick with investments in a technology to scale it up. There are challenges in developing the entire supply chain, from the feedstock to the financing of the facilities. That's the challenge right now. So it's somewhat between technologies. There are a lot of technologies out there that are viable technologies, but it's scaling up, which involves just sort of business management as well as testing out the technologies, rather than inventing new biofuel production techniques per se.
Valerie, my name is Saeed Majdi. I'm with the Integral Scientific Institute. Whenever we have a solution or a potential solution that we want to apply to the, for example, the global warming problem, beyond the solution itself, we try to look at its impact, specifically using the systems thinking. We look out for things like unintended consequences. So, in the use of biofuels, what kind of unintended consequences are you considering and watching out for?
Okay. So, many of these have been identified by other people. One issue is that most of the biofuel feedstocks use land. And that land could be agricultural land, it could be forest land. And we use petroleum globally at a very large rate. So it's a substantially large industry. So how the choices about how land is used can be it's just a major problem, both for food production and just land for nature or land for any other application. So just efficiency and thoughtfulness are very important. Another issue is the smaller scale this problem can be, the easier it is to solve. So there's that set. There's another set of problems that with biofuel, if we're not talking about just a niche market, but really that biofuel would replace a substantial amount of petroleum fuel, and that other segments of petroleum fuel would be replaced by, electric vehicles for ground transportation, that kind of thing. There's sort of globally, in many nations, there's a lot of dependence on production of petroleum as an economic basis for economies. And we're seeing that now with a very low cost of petroleum. So I think one consequence, if this were actually successful, if it were going to be real, is that the kind of disruption you're seeing now, Venezuela, for example, with very low petroleum prices will continue. I think it's likely as you start producing much more biofuel, if you have much more electric vehicle production to the point that they're deeply or even slightly cutting into real markets for petroleum prices are going to stay extraordinarily low for decades, and that will have geopolitical consequences.
So I'm also thinking about, you mentioned land use, but there's also the water use and the emissions that result either from the plants or the animals that help in producing those biofuels. So it's a little more complicated, and I think it needs closer analysis to determine the exact final outcome when it comes to the impact on the environment.
Yeah, I agree.
Hi, my name is Anthony Diorsi. I do consulting work for tech companies that do business in China. The firm is there, and I used to live there. My question would be, when you're looking at the business case for biofuels with these aviation companies, what is the typical catalyst? Is it usually pressure to reduce emissions? Is it usually something like energy security, such as the case sometimes in China due to the fact that they rely heavily on imported oil? Or is it this case-to-case based on geography?
So the business case, there's kind of several business cases. Like if there is government involvement in supporting the biofuel industry or supporting innovation, then you're looking at kind of the national interest, which can be several. So one is national security, having a source of liquid transportation fuels that are produced locally or nationally, or that are just different from the main supply routes. For airlines, there's certainly the pressure to do something about carbon emissions, and I think there is also the desire to demonstrate to customers their commitment to doing that, and also there is an interest in developing expertise and getting into this field early to reap some of the benefits of being the first mover. We see that. So if you're thinking about being able to scale up this technology and produce at scale, there are advantages in getting in kind of, fairly early and being able to be the owner of the technology. That is a low-cost way to produce biofuel. So there's that advantage as well. So there are different customers along the chain that would have different business cases, and they all have to line up, which is one of the tricks that we're trying to do.
Do you happen to know what the initial impetus was for Cathay Pacific to begin using these biofuels? Just curious, I'm not sure if you have.
No, I don't know specifically what drove them to do that. I think it's interesting that the supply chain is that the airplanes are fueled in Toulouse, France, using biofuel that I believe is made in, you may know better than me, but made in Brazil. So it's definitely not a kind of final setup of a long-term supply chain, but kind of developing that capacity to use that.
So it was probably fuel that was produced in Brazil and transported the U.S.
Yes.
Now,
Yeah, to France.
Ships to France.
Yeah.
It's complicated.
Yes.
So the difference will last, so that makes some amount of, it's still okay for right now.
Sure.
You can do something.
Sure. Yeah. It's also good marketing for the airlines.
Yeah.
No, every airline likes to be able to have their magazine and talk about that they use some biofuel somewhere.
The green airlines.
Yeah, and there is a variation in how they're approaching this, different airlines.
Are we wrapping up?
Yeah, so so it is 12, a little bit before 12:30. So Jim, the moderator, is going to be, we'll be wrapping up the session. If anyone wants to keep chatting, that's fine. We're just going into lunch. You're not going to miss any other sessions. And so I guess I'll keep you here in case anybody wants to.
Certainly don't want to miss lunch.
No, you don't want to miss lunch.
Yeah, and thank you very much for talking with me. This was great.
Thank you, Molly.
Thanks. Glad to have met you.
Well, wonderful. Well, thanks so much for joining us. I'm so glad the connection stayed